Hello everyone, let's start with this new question. The question is, which of the following has only one subset? We have been given four options here, out of which we are supposed to identify the set with only one subset. But before we do that, what do we know? We know that if there is a set with n elements, I can get the number of subsets by 2 power n. Now, we'll use this rule to identify which one has one subset. If we take a look at first option, this one is a empty set. So how many elements? 0 elements. What do we get? The number of subset is 2 power n, which will give us 2 power 0, which is equal to 1. If we take a look at here, how many elements does it have? 1. Only one element here. The number of subset is 2 power n, which is 2 power 1, which is equal to 2. If we take a look at third here, the third option has 2 and 1. So we have here 2 elements, out of which we can say the number of subset is 2 power n, so 2 power 2, which will be 4. And finally, for this one we have 0, but it's still element, so number of element is 1, and the number of subsets would be 2 power 1, which is 2. Now if we take a look here, which option has one subset? Option A. Then the correct option would be option A. Alright guys, for this question what do we need to do? We have three sets here, A, B and C. What is set A? 1, 2, 3, 4, a set containing 4 elements, and the elements are 1, 2, 3, 4. Set B is the set of prime numbers, and set C is set of positive even numbers, and we are supposed to find the universal set U, and we have the option natural number, integers, real numbers and all of this. Let's try to see which could be the answer. For this one, what is the set A? The set A given to us is 1, 2, 3, 4. Set B is set of prime numbers. And we know what are prime numbers: 2, 3, 5, 7, 11 and so on. Set C is set of positive even numbers. That means 2, 4, 6, 8, 10, 12 and so on. And we are supposed to find the universal set U for this three sets given to us. To do that, what are we supposed to find? We are supposed to find a set which has all the elements of these sets in a single set, that is universal set U. For that, what can I do? To simply do that, I can just do the union of these three sets, that is A union B union C. So we'll get all the elements which are present in any of this set. And if I do the union, what will I get? 1, 2, 3, 4, 5 is present here, 6, then 7 is here, again 8 is at set C, and then 10, 11, 12 and so on. So if we take a look here, we have all the positive numbers, but some number are missing. Here 9 is missing, then after that we would have 13, we would have 14, we would have 15, 16, 17, and then some numbers might be missing. So if I want to write the given universal set should contain this elements. And if I take a look at the options now, we have four options here. Option A is natural number, option B is integers, option C is real numbers, and option D is all of this. Now what do we know? That universal set is a set which should contain all those elements. If we take a look, can I say these elements are also present in natural numbers? Yes, I can say that. So in this case, universal set is a subset of natural number. So if I have this universal set and it is a subset of any larger set, that larger set could also be the universal set. So for now I can say natural number is also the universal set. Now we also know that natural number is a subset of integers, and integers is a subset of real numbers. The required elements are present in this universal set U, and all these given options N, Z, R are larger sets in comparison to U. So any of this set could be my universal set. That's why the answer would be all of this. The universal set could be natural numbers or integers or real numbers. That's why option D.